everyone. Today we're going to have you work on lesson 7 from unit 4. So please take a moment to open up your notes packet to lesson 7. It should be titled Solving Polynomial Equations with Complex Solutions. So we have solved polynomial equations before in our previous unit. So the start of this is going to feel very similar. So when we're asked in number 1 to solve algebraically for all values of x, the first thing we're going to do is get our equation into standard form. So I'm going to add the 16x to the other side. Once set equal to 0, I'm going to think about what factoring method I would use to solve for x. So the first factoring method we should always consider when approaching any factoring problem is to look to see if we have a greatest common factor. So looking at these 4 terms, I can see that they all have an x in common. So I'm going to factor that out, and then I would be left with x cubed plus 4x squared plus 4x plus a constant of 16. Now what's in the parentheses still needs to be factored, and we have 4 terms. So this looks like a grouping problem. I'm going to split it down the middle, look to the left 2 terms, and factor out an x squared, which is going to leave me with x plus 4. And then with my right 2 terms, if I factor out a positive 4, I'm also going to get x plus 4. I also don't want to forget that I have this GCF in front of x, and that this is an equation. Now I'm going to take my x squared and my 4, going to group them together. They're both together as a binomial, multiplying that common factor of x plus 4. And then I'm going to bring down my GCF factor of x and set this equal to 0. Now, it would be tempting to think that we could factor the binomial x squared plus 4 a little bit more, especially because we have an x squared still in the factor. However, this is not the difference of perfect squares because we have this plus sign. So what I'm going to do is when I go to solve and set each of my factors equal to 0, I'm going to let this factor be equal to 0 and see what result I get, because I cannot factor it anymore. Let's just make that note. Cannot be factored more. If you want to even say it's not dots because there's a sum. So now let's take each factor and set them equal to 0. So for my first factor, x, I'm just going to get an answer of x equals 0. And from my last factor, x plus 4, when I set that equal to 0, I get an answer of x equals negative 4. So the new piece here is that we're solving this factor x squared plus 4 equals 0. Let's see what happens. So if I subtract 4 to the other side, I get x squared is equal to negative 4. Now when you want to solve or undo a square, you would use a square root. So I'm going to square root both sides. And now I'm square rooting to solve, so I can't forget that there should be 2 answers. So I'm going to put a plus or minus. Now, in your calculator, if you tried to type this in, you're going to get an error message. So what I'm going to have everyone do right now is break up this number a bit. The error message is coming specifically from the fact that this number is a negative number. So what I'd like you to do is separate negative 4 into 4 times negative 1. And then we're going to do one step more, really separate this. We're going to give a square root to the 4 and a separate square root to the negative 1. So we can really separate it because we know what this is equal to, right? We know that the square root of 4 is equal to 2. So I have plus or minus 2. What we don't know is what the square root of -1 is equal to. Because right now, all our calculator is telling us is that it's a non-real number. And that's true. The square root of -1 is a non-real number. It's something that we're going to now refer to as an imaginary number. We're going to dive much deeper into this in our lesson 5, imaginary number lesson, tomorrow. So for all you need to know for today's lesson is that the square root of -1 is equal to a number we're now going to call I. And you might want to write that maybe in your notes. The square root of -1 is equal to I, and what I is an imaginary number. So we said it's non-real. You could also say that it's a non-real. That's the error your calculator gives you. So you could refer to it either way. An imaginary number or a non-real number. So when we get a number under a square root that's negative, the -1 as its own factor is producing this new imaginary number called I. The square root of the other value, the non-negative part, is going to simplify the way that you're used to simplifying it. The square root of 4 is still equal to 2. So what we have in this answer to this question are two real numbers. -4 and 0 are real, right? Those are numbers that we're used to getting. Plus or minus 2i, there's really two answers coming out of that, are non-real answers. So we have two real number answers and two non-real numbers. Now let's count up our answers. We have 4 in total, right? 2 real, 2 non-real. And if we go back to the degree of this polynomial, that should make sense. Because it's a 4th degree polynomial, we should have 4 answers. Now, I'm going to show you a picture of the graph. And we'll get back to that line in a moment. You can see here, I zoomed out when I typed this into my y equals. I actually typed into my y equals the standard form equation. So I brought that 16x to the other, so -16x to the other side. And you can see the -4 and the 0. What you don't see are any other x-intercepts, because you will never see x-intercepts if they're associated to a non-real number. The x-axis only contains real numbers. So real numbers will be on the x-axis. If you have non-real answers, you're just going to see your graph never come in contact with the x-axis for that amount of solutions that you have. So even though this is a 4th degree polynomial and we might expect to see either 4 x-intercepts or maybe a turning point x-intercept that counts as 2 and 2 other x-intercepts, we're only seeing the 2 real values. The 2 non-real do not connect with our x-axis. Now this line above the graph that says that when equation has non-real roots, they occur in conjugate pairs. I just want you to understand what conjugate means. So we had a 2i and a -2i, the plus or minus. So a conjugate pair is just that. It's values that just have an opposite sign. So other conjugates you would have seen before is just an example. A conjugate pair, if you were factoring, let's say by dots, x squared minus 4. So just an example of what a conjugate is. That factors to x plus 2, x minus 2. These are called conjugate pairs. Because one has a plus 2, one has a minus 2. So when you get imaginary answers or non-real answers, there's always going to be a pair of them. So you'll never just get one or an odd amount. Okay, what I'd like to do now, just because this is new and you're watching a video for this, let's take a look at the first practice question together, and then I'll give you some time to work on the rest of the practice. So for number 1 in the practice, we're going to, again, take a look at this polynomial and try to solve for the roots. So it's already in standard form. I can see, though, that I do have a greatest common factor here. So my greatest common factor is 3x, so I'm going to factor that out. I'm going to get x to the 4th minus 48 divided by 3 would be 16, and then the x is also being factored out. Looking at x to the 4th minus 16, that's the difference of perfect squares. So I'm going to break that down into x squared plus 4 and x squared minus 4. And now between the two binomial factors I have, one has a plus, one has a minus. The one with the minus is still additional factoring by dots. The one with the plus is factored completely. So x squared minus 4 can be factored into x plus 2, x minus 2. So again, we started with the polynomial to the 5th degree. So we're expecting to get 5 answers. I'm fully factored since x squared plus 4 cannot factor any more. So for 3x, set that equal to 0, divide by 3, you get x is equal to 0. I'm going to come back to the x squared plus 4 again. So x plus 2 equals 0, so x equals negative 2 is an answer. X minus 2 equals 0, so x equals 2 is also an answer. So we have 3 real answers: 0, negative 2, and positive 2. And then x squared plus 4, similar to the one we did before, when I go to take the square root of x squared and the positive negative square root of negative 4, remember, we're really seeing the negative 1 or the 4 separately from the negative 1, and we get a positive negative 2i. So 3 real roots and 2 non-real roots. And if we look at the graph here, again, I did play around with the window to really show you the full picture. You can see 0, 2, and negative 2, but there are only 3 x-intercepts because the 2 non-real answers do not ever connect with the x-axis. Okay, so what I would like you to now do is try numbers 2 and 3 in the practice, and the answer key is posted on Canvas that you can check in with while you work.